and welcome to class. This is another class on geometry. So I hope you are ready to learn more about geometry. So in the previous class, we learned different types of angles. We learned the angles on a straight line, angles at a point. We also learned acute, obtuse angle. We learned complementary and supplementary angles. So right now we want to continue learning by learning angles on parallel lines. So that's what we'll be learning right now. Angles on parallel lines. Now, what are parallel lines? Parallel lines are lines that move in the same direction and they don't meet. They are straight lines that move in the same direction and they don't meet. Now look at parallel lines. These are two straight lines with arrows showing that they are moving to the right. So they are moving towards the same directions and they don't meet. They can never meet. So the parallel lines can either be horizontal or they can be vertical or they can be slanted, but make sure they are moving towards the same direction. So these are vertical parallel lines. Then you can have slanted parallel lines. So these are what we call parallel lines. Now what makes angles on parallel lines? Now with parallel lines we have what we call transversal. We have what we call transversal. Now transversal is a line that divides parallel lines. So these are two parallel lines with another line crossing the two parallel lines. So this line crossing the two parallel lines is what we call transversal. So a transversal is a line that divides parallel lines. And when you have a transversal, then with this transversal, you can have many angles on the parallel lines. So having known what parallel lines are and what a transversal is, now let's proceed to learning the different types of angles on parallel lines. So the first type of angle is corresponding angle. Corresponding angles. Now, corresponding angles are angles that are seated on the same direction, in the same direction on both parallel lines. Okay. Each angle on each line is in the same position of the transversal. Now, don't forget that this is the first type of angle. So we have parallel lines. We have transversal. So when angles are seated, angles seated on the same position of the transversal on parallel lines. Now what do I mean? I mean if you have this angle as x on the first parallel line, on the second parallel line it has to be on the same position of the transversal. So this place will also be x. So you can see that on the first parallel line, the angle is on the left side on top of the parallel line. Then on the second parallel line, the angle is on the left side on top of the parallel line. So which means they are on the same position, all right? Now look at this. If this is also B, then this side will also be B because they are the same position of the transversal. The first parallel line has B on top, has an angle on top of the line on the right side. Then on the second parallel line that is below, you also have that angle on top on the right side. On the right side and on top of the line. Now what if we have below, right here, you have C. Then you come to the second parallel line, you also have C. Which means those angles are corresponding to each other. They are corresponding to each other. Now let's have this now. Let's have figures right here. So you have the parallel lines facing the same direction. Alright, so let's have this example where right here we have 70 degrees and on the left side we have 110 degrees. You know, sum of angles on a straight line will give you 180 degrees. So the sum of these two angles definitely is 180 degrees. So what are the corresponding angles? Now you can see 110 degrees. It means right here, this angle is also 110 degrees because they are the same position of the transversal. On the left side, on top of the parallel line, the first parallel line has 110 degrees on top of it on the left side. So the same thing goes for the second parallel line on top of it on the left side. Now, below right here is also 70 degrees. It means below the second parallel line on the left side, you also have 70 degrees. So on top of this parallel line right here, it will be 70 degrees because on the first parallel line on top of the parallel line, it is 70 degrees. So below right here, we'll be having 110 degrees. It means the same thing goes for the second parallel line below it on the right side. It will be 110 degrees. So this is how to identify corresponding angles. Now let's move on to the second type of angles. It is called alternate angles. Alternate angles. So what do we call alternate angles? Alternate angles are two angles formed on opposite sides of the transversal within two parallel lines. Okay, these are angles formed on the opposite side of the transversal on two parallel lines. So now these are the two parallel lines. Right here is the transversal. So if we have 70 degrees here and 110 degrees here, how do we know the alternate angles? Now, alternate angles is the opposite side. So now, for instance, on the first parallel line, the parallel line that is above, we have 110 degrees on the left side and on top of the parallel line. Now, what is the opposite of left on top? Okay, the opposite of left is right. So you go to the second parallel line on the right side. Then what's the opposite of on top? That's below. So on this second parallel line, it will be on the right side below. Okay, on top, on the left. So on the next parallel line, that will be below. So let me change the dimension of these angles. So here should be 70 degrees, while here should be 110 degrees. So let's look at it. The left side above. So you come to the second parallel line, it will be right side below. So that's what we call opposite side of the transversal. So right side of the transversal below the second parallel line. So which means this particular angle is alternate to 70 degrees. Okay, that angle is alternate to 70 degrees. Now let's look at that of 110 degrees. Which angle is alternate to 110 degrees? Now this is on the right side on top or above the parallel line. So what's the opposite? That will be left. You come to the left, then below. So this will be the alternate angle. So right here will be 110 degrees. So this is how to identify alternate angles. So let's say right here you have 110 degrees. So what's the alternate angle for this particular angle? So this side, you're on the left side below. So the opposite is right side above. The opposite is right side above. So this is the right side and this is above. So this is 110 degrees. So right here we have 70 degrees, and that means the opposite side right here we will also have 70 degrees. Now another name for alternate angles is what we call Z angles. We call Z angles. Why do we call Z angles? Now if you look at the letter Z, you can see that we have an angle right here, let's say angle A. So if this angle is A, it means this angle will also be A, because they are alternate, because when you look at it very well, Z looks like a parallel line. Can you see that? So parallel lines. Then this slanted line of Z is a transversal. Okay, is a transversal. So that's why we were able to call it Z angle. We're able to call it Z angle. Okay, so this is how to identify alternate angles. So now let's look at the next type of angle. The next type of angle is what we call vertically opposite angles. Don't forget we are learning angles on parallel lines. Let's see vertically opposite angles. So that will be the third type of angles. Vertically opposite angles. Vertically opposite angles. Now, what do we mean by vertically opposite angles? These are angles formed opposite each other. Okay, where two lines intersect. Okay, these are angles formed opposite each other. These are angles formed opposite each other, where two lines intersect. So we call vertically opposite angles X angles, and you're going to learn why. Now these are the parallel lines, and this is the transversal. So if this side is A degrees, now which angle is facing it? This angle is facing it, so this side will also be A degrees. Now let's look for more opportunities. Look at this particular angle. If this particular angle is 105 degrees, it means the angle facing it, which is opposite to it, is also 105 degrees. Now look at this angle also. This angle is A degrees. The one opposite it, okay, that's the angle facing it, will also be A degrees. This particular angle is 105 degrees. The one facing it, which is opposite, is also 105 degrees. That's why we call it X angle. You can see that the transversal and the parallel line intersect each other. So the angles that are formed facing each other are called vertically opposite angles. So that's why we call vertically opposite angles X angles. So this is equal to this angle, and this right side angle is also equal to this left side angle. So I hope you understand. So now the next type of angle you're going to learn is what we call adjacent angles. Adjacent angles. So adjacent angles are angles separated by a common line on a straight line. They are angles that are separated by a common line. They are separated by a common line on a straight line. On a straight line within the same angle. So sometimes you have them within the same angle. Now, these angles are also two angles on a straight line beside each other. So they can also be two angles, two or more angles. two or more angles beside each other on a straight line. So we still have parallel lines, and you have the transversal. So you have 65 degrees here, and on the other side here you have 115 degrees. Now 115 degrees and 65 degrees are called adjacent angles. They are called adjacent angles. They are angles that are adjacent to each other. Now this is another example of adjacent angle in an angle. This is an angle already. You now have two other angles in it. So you can have maybe angle 45 degrees here, and maybe right here you have angle 16 degrees. So these two angles are adjacent to each other. They are adjacent to each other. So we also call them adjacent angles. So let's solve some examples together. Let us solve some examples together. So we're going to find the missing angles in the diagram below. Find the angles marked with letter. In the diagrams below. So let's find the angles that are marked with letters in the diagrams below. So this is the first one. So we have the two parallel lines. Don't forget, the parallel lines are lines that can never meet. And the transversal is the line that divides the parallel lines. So right here we have Y, below we have X, and the other angle below is 115 degrees. Then we have angle A. So we have to find the missing angle, that is the angle that has been marked with a letter. I hope you are ready. So now let's look at it. Let's look at it together. Now the first letter we need to figure out here is the letter X. Now X and 115 degrees are on a straight line. They are straight line angles. So that will be X plus 115 degrees is equal to 180 degrees. Always give reason. So I'm going to open a bracket so I can write the reason the sum of these two angles is equal to 180 degrees. It is because they are straight line angles. So always give the reason. That's what earns you marks during examination or classwork. Straight line angles, or you say angles on a straight line. So that will be X equals 180 degrees minus 115 degrees. That's equal to 65 degrees. So the value of X here is 65 degrees. Now what is Y? Now if you look at Y is vertically opposite to X. Y is equal to X because there are two angles facing each other. They are opposite each other on two lines that are intersecting each other, X angle, okay? So we said they are vertically opposite. Always write the reason. Vertically opposite angles. Always write the reason. So if at this point you are yet to master the 4 types of angles on parallel lines, please make sure you attend this class again. No one is going to scold you. You're not going to have your ears twisted like other teachers do. But you can always learn without anybody scolding you at your own pace. So I advise you to rewatch this class up to 3 times so you can have mastery of this topic. All right, so if Y is equal to X and X is 65 degrees, it means Y is also equal to 65 degrees. So we have gotten the value for Y. So what is the answer for A? So what is A? So what is the value for A? Now if you look at A, let's see if we have a corresponding angle to A. Don't forget corresponding angle. Now, A is on the right side on top of the parallel line. Then look at the parallel line above. On the right side on top of the parallel line is y. So A is equal to y because they are corresponding angles. So always write the reason. Don't forget corresponding angles. So if y is equal to 65 degrees, it means A is equal to 65 degrees. So we've been able to find the value of the angles marked with letter in this particular diagram. Now let's move on to the next example. The more you do this, the better you become at math. So now we have parallel lines right here. I'm going to have this drawn this way. Yes. So when you see something like this, how do you get it done? You should be happy when you see something like this because it's going to task your brain. So I have theta right here. Then right in this angle, I have beta. Then I have 125 degrees right here. So, and outside here, do I have another angle? No, I don't. I don't think I have another angle. Okay. So what is the value of theta and beta? Now, sometimes you may need to find a particular angle first before you are able to find the angle that you have been given. I hope you understand that. Now, look at this. Let's extend this parallel line. I'm going to name this first line from point A to point B, and I'm going to extend it from point B to the right side, making it point C, because that line has to be extended so I can properly see my parallel line. Then for the transversal also, I'm going to extend it above. I'm extending it above. Then I also come to the second parallel line. I'm going to extend it also. Okay, so I can name it. So I have point D, I have point E, then the extension is to point F. All right. Then if you observe very well at the middle right here, you can see that we have another parallel line. So it means we'll be having 3 parallel lines. So I'll be extending that inside. I'll be extending this to the left with dotted lines. I hope you can see it clearly. Now this will enable me see better. Okay, so when you are being given something like this, you just extend the lines so that you can have full lines. Extend the lines. I'm also going to extend the transversal below. I'm extending the transversal below. So yes, we have 3 parallel lines and 1 transversal cutting or dividing the parallel lines. Now, how do I find the unknown angles? Now, I have 125 degrees as the only given figure. So what I'm going to do is I'm going to look for the adjacent angle. An angle is adjacent to 125 degrees, which is right here. So I'm going to name it M. So 125 degrees and M are angles on a straight line. So the sum of these 2 angles will be 180 degrees. And in brackets, I will say angles on a straight line. Angles on a straight line. Angles on a straight line. So that will be M equals 180 degrees minus 125 degrees. And that will be equal to 55 degrees. All right. So since I have 55 degrees right here, so what will be the value of beta? Now, look at beta. And I'm already having my M as 55 degrees. So, which means beta is equal to M. Why is beta equal to M? It is because they are alternate angles. I have looked at it, okay? They are alternate angles because beta is on the left side under or below the parallel line. Then I'll come to the right side above the parallel line. You can see that it's alternate. So beta is equal to M, and that means beta is equal to 55 degrees. So what will be the value for theta? So we have to find the value for theta. Now, if you look at theta very well, we can see that theta is also on the right side of the second parallel line and on the parallel line. Is on the right side and above the parallel line. So do we have anyone that can be corresponding or alternate? I don't have a corresponding. Do I have corresponding? Yes, I have corresponding angle. So theta is corresponding to angle M, and it is alternate to beta. If you look at it very well, theta is alternate to beta. Theta is on the right, beta is on the left. Theta is above the parallel line, beta is below the parallel line. This is beta right here. So it is alternate to beta and it is corresponding to angle M. You can see that angle M is 55 degrees on the same direction of the transversal. So which means my theta is equal to beta. The reason is alternate angles. Alternate angles to beta. Now, what is theta to angle M? It is corresponding to angle M. So I would say theta is also equal to M. They are corresponding angles. Corresponding angles. So it means that theta is equal to 55 degrees because beta is 55 degrees and angle M is equal to 55 degrees. So theta is equal to 55 degrees. So we've been able to find the angles that have been marked with letters. So I hope you understand. Don't forget, you can always attend this class over and over again so you can have in-depth understanding. So now let's move to the third example so we can understand better. So that when you see this kind of question during your examination, it will be easy for you to do. Now I'm going to have three parallel lines. I have one right here. So this is one parallel line and I'm going to have another parallel line. This is another parallel line. Then I'm going to have some lines drawn at the middle. So please pay attention. I have a line right here and I have a line straight to the other parallel line. So I have these two major parallel lines. These are my two major parallel lines. Then I have another parallel line at the middle right here. So which means I have three parallel lines. So right in this angle, it is D. Then this angle is 135 degrees, while the one adjacent to it is angle A. Then I have angle X. Right here is angle X. I have angle X. Then this little angle is 16 degrees. Particular angle right here is angle Y. So how do we find the angles that are lettered? Now you can see that this is a particular question. So how do you do this? Don't forget what I said. I said extend the parallel lines. So I'm going to extend this particular one that is at angle X. I will extend it out with dotted lines or broken lines so I can see. Okay, then the transversal also, for this first transversal on my left, I can extend it out right like this. I hope you can see. And I'm also going to extend the other transversal to the left. So for all the lines that are not well shot out, I'm shooting them out. So I have extended everything. So this will give me a good view of what I need. Now, if you look at it very well, we have angle 135 degrees on the left here, and 135 degrees and A are adjacent angles. So an adjacent angle on a straight line has its sum, they have their sum equal to 180 degrees. So A plus 135 degrees is equal to 180 degrees. We can say they are adjacent angles, or they are angles on a straight line, or angles on a straight line. Okay, we can say they are angles on a straight line. So we're going to have A equals 180 degrees minus 135 degrees, and that will give us A is equal to 45 degrees. So that's the value of A. So now with us having the final answer as A, so we should be able to get other angles. Now, what will be the value of angle D? Let's see, using Z angles. Look at it. A on the left side, if you can turn the parallel lines to be straight, you see that A is on the left side. This is the transversal. A is on the left side of the transversal. Then if you look at the right side of the transversal, above the parallel line, you have angle D. So A is alternate to angle D. So it means A is equal to D. So that will be D is equal to A, and that's equal to 45 degrees. The reason is they are alternate angles. They are alternate angles. So angles A, D, A, and D are called alternate angles. Now we've gotten the angle D. Now we need to get angle Y. We need to get angle Y. So can we find angle Y before we find the value of angle X? So let's see. If you look at the transversal of Y, Y is an angle on the transversal, okay? On the transversal and on the parallel line. Now let's look at the transversal. Let's see if there is a corresponding angle. Y is supposed to be corresponding to this angle D, and let me just name this angle M. Any angle we are not giving, I'm giving it angle M. So angle D and M are supposed to be equal to angle Y. Okay, they are supposed to be equal to angle Y. That will make them corresponding to Y because they are on the same position with this particular transversal. The transversal for Y, if you extend it with this dotted line, you see that they are corresponding. So how do we get angle D and angle M? We already have angle D, but how do we get angle M? If you now look at angle M again, you will see that it is vertically opposite to this particular angle. This, let me name it angle P. It is vertically opposite to this angle P because where angle M is positioned, we have two lines intersecting each other. Now I'm going to change the color of my pen. Okay, so you can see right now. So you can see right here, we have angle M right here, vertically opposite to angle P, but we don't know angle P. So before we find the angle Y, we may have to find the angle X, and here is angle X right here. So we already have angle D and angle 16 degrees. Angle D and angle 16 degrees, let's look at it. Look at this transversal and this other transversal intersecting each other. They're intersecting each other, so which means angle D and 16 added together will be vertically opposite to just this part of angle X. Don't forget that angle X is actually from this point, from M to P is angle X all together with this particular portion. So, but let's look at this first. So angle D and 16 added together. Angle D is 45 degrees. Add it to angle 16. What will that give us? So 45 plus 16 will give us 61 degrees. So which means vertically opposite, this place is 61 degrees. So how do we get angle M and angle P? How do we find the value of angle M and angle P? Now, still looking at it, you also need to look at this transversal, this particular transversal that has been extended. So we need to find angle P in order to be able to get angle M. And everything, all these angles at the points, they are also called angles at the point. And you know that angles at the point will be summed up to 360 degrees. So now let's carefully study. We already have 61. Now right here is another parallel line. We have a parallel line right here. Can you see? So now let's use this parallel line plus the parallel line on the left right here to get this angle. Now 135 degrees is corresponding to this whole angle right here. okay, because 135 degrees is right here below the first parallel line on the right. And also on the right, below this other parallel line, also we have this angle, so it's corresponding. So which means if this place is 135 degrees, the totality of this angle is also 135 degrees. That is 16 plus P should give us 135 degrees, okay? So 16 degrees plus P equals to 135 degrees. So it means P is equal to 135 minus 16, and that will be equal to 119 degrees. So it means the angle for P here is 119 degrees. So if P is 119 degrees, vertically opposite angle. So P is vertically opposite M. The angle P is vertically opposite to angle M. So angle M here will also be 119 degrees. So now we should be able to get the answer to X degree as an angle. Okay, we should be able to get the answer for X. So now we'll be adding up 119 degrees plus 61 degrees plus 119 degrees. Don't forget, 119 degrees plus 61 degrees plus the other 119 degrees, and that will give us the totality of angle X. So angle X is equal to 119 plus 61 plus 119 degrees. So what will that be? So if we add 119 to 119, that will give us 238. Plus 61, that will give us 299 degrees. So angle X is equal to 299 degrees. I hope you understand that. So what will be the value of Y? What will be angle Y? So, having gotten other angles, let us find angle Y. Now, if you look at angle Y very well, angle Y is corresponding to a particular angle on the other parallel line. That is this parallel line and looking at this parallel line. So angle Y is on the right side of the parallel line right here and above the parallel line. On the right side of the transversal, let's look at the transversal, which means we have to add 119 degrees to 45 degrees, okay, to get our angle Y. We have to add 119 degrees to 45 degrees, and that will give us the angle Y. 119 plus 45, that's corresponding angle. So 119 degrees plus 45 degrees. So the reason is corresponding angles. The reason is corresponding angles. So Y will be equal to 164 degrees. So that is the value of Y. So having learned corresponding angles, alternate angles, vertically opposite angles, and adjacent angles, you should be able to find the missing angles on parallel lines. Now this is your exercise. We have learned, and I want to see how far you have understood. Now you're going to do this. So find the value of the angles marked with letters. Find the value of the angles marked with letters. So I'm going to give you parallel lines also with different transversal. So we have the angle Y here. So these are the parallel lines. We mark our parallel lines with arrows showing the direction. Then right here we have angle X. So this transversal forming a triangle, we have 54 degrees. Then right here you have 39 degrees. So you have to find the value of X and the value of Y. Now, before doing that, you may need to watch this video class again, okay, so you can understand better and you can learn more. But I'm so excited that I am impacting knowledge into all the students right here. I hope you enjoyed the class. If you're watching on YouTube, please click the subscribe button and make sure you like and drop something in the comment section so that your friends can also attend this class. Don't forget to share this class with them. So thank you and have a wonderful time. I'll see you some other time. Goodbye.